Hi students, how are you? Today, let us begin a new topic in chemistry, general principles and process of isolation of elements. In this lesson, we shall learn about metallurgy and the process of obtaining pure metal from ores. Welcome to this section. The process used for the extraction of metals in their pure form is referred to as metallurgy. We know that metals found in earth crust are in the form of compounds called minerals. For example, aluminum metal in earth crust found in different minerals form like bauxite. The formula of bauxite is Al2O3 and aluminum chloride AlCl3, etc. But aluminium profitably extracted from bauxite. So bauxite is considered as ore of aluminium. Another important example is hematite. Hematite, the formula is Fe2O3, is considered as ore of iron because iron is most profitably extracted from Fe2O3 compared to any other mineral of iron. So in general we can state that all ores are mineral, but all the minerals of metals are not ores. Extraction of ores from the earth crust involves mining. In mining stage, ores may be contaminated with the earthy or undesirable materials known as gangue or impurities. After removing impurities, ores become pure. Now let's discuss about steps of metallurgy. Pure metal may obtain from the ores through 5 steps. First step is crushing and grinding of ores. B. Concentration of ore. Third step is conversion of concentrated ore to oxide. Next is reduction of oxide to metal. Last step is refining of metal. Now I am going to explain the metallurgical steps in detail. The first step is crushing and grinding of ores. In this method, ores are crushed into a fine powder in a big jaw crushers and ball mills. This process is also called pulverization. Next step is concentration of ore. Concentration of ore means removal of impurities or a gangue from the ore. The concentration of ore based on the nature of impurity and the ore. There are various techniques used for this purpose. And the first concentration technique is hydraulic washing or gravity separation. In this method, ore and gangue particle is washed with a stream of water under pressure so that the lighter impurities from the ore washed away and heavier ores left behind. So this method is based on difference in density of ore and gangue particles. Next concentration method is magnetic separation. If either the ore or impurities are magnetic, we can use magnetic separation for purifying the ore. Let's see the figure. In this method, the finely grounded impure ore is placed on a conveyor belt and it is attached with two rollers, and one of the roller is magnetic. So when you place the impure ore contains magnetic and non-magnetic material. Sometimes ore is magnetic or impurity is magnetic. When you place this impure ore on the conveyor belt, at the time of rotation, the impurities or ore which is magnetic. Out of these two which is magnetic, that magnetic part will attract it to the roller and form a heap near to the magnetic roller, and the non-magnetic particle, either ore or impurities, non-magnetic particle form a heap away from the roller. So like this you will get two separate heap of magnetic and non-magnetic particles, and this method can mainly used for separating magnetic or non-magnetic impurities from the ores. Here a clear application of magnetic separation is given. It is used to concentrate magnetite, chromite and pyrolyzate from unwanted gangue, because all these ore parts or all these ore are magnetic and the gangue are non-magnetic. So we can use magnetic separation for separating these ores from the impurities. Next method of concentration of ore is froth flotation process. Froth flotation process mainly used for sulfate ores. For example, for the purification of copper sulfate, zinc sulfide and lead sulfate ores, we can use froth flotation process. The main principle behind this process is the mineral particles become wet by oils while the gangue particles by water. It means the mineral particles or ore particles more attracted towards oils, while the gangue or impure particles are more attracted towards water. This process can easily explained by using a figure. Let's see the figure. The first step, take impure ore and water in a large tank. Then add oil. An example example for oil is pine oil. Add pine oil to the mixture of water and impure ore. Oil is mainly taken for creating froth in the tank. So pine oil is also called collectors. Pine oil is one example for collectors. We can use other chemical also for producing the froth, and more about collectors we'll discuss in the next slide. And after forming froth, to stabilize the froth we can use froth stabilizer, and more example we'll discuss in the next slide. One example of froth stabilizer is aniline. After mixing impure ore, oil and water will form a suspension mixture. After that, rotate this mixture by using a rotating paddle with the help of air. After mixing the mixture will form froth. The froth is mainly formed due to oil. So main reason behind froth is oil, and we already discussed the principle of this process. We already discussed it. We know that from the impure ore, the ore always attracted to the oil part, that means froth, and the impurity always will attract it to the water. So impurity will settle down in the tank along with the water, but the pure ore will move towards froth, because froth is formed from oil. After forming froth, the next step is collect this froth into another beaker. From the another beaker, we can recover ore by drying this froth. Like this, we can concentrate all sulfate ores by using froth flotation process. Collectors. Collectors mainly used for producing froth in froth flotation process. Examples are pine oil, fatty acids and sandides. Froth stabilizers. Froth stabilizers are chemical substances which stabilize the froth. Examples are creosotes and aniline. If two sulfide ores, example zinc sulfide and lead sulfide, mixed together in froth flotation process, both sulfide ores will form froth. From the froth, separating zinc sulfide and lead sulfide becomes difficult. Like these cases, we can use depressants. One example for depressant is sodium cyanide. When we mix sodium cyanide along with these two ores and agitating the entire mixture, this sodium cyanide allow only PbS lead sulfate to form froth. Zinc sulfate again remain in the water. So from the froth we can easily separate lead sulfate. And here sodium cyanide is called depressant. Next method of purification is leaching. It is often used if the ore is soluble in some suitable solvent. It is a chemical method used for purification of ore. It is mainly used for purification of alumina or bauxite. Alumina mainly consists of two types of chemical impurities, iron oxide and silica. These impurities can be removed by using leaching. Already I said it's a chemical method. First, the ore is treated with sodium hydroxide. The ore is treated with the sodium hydroxide, then water to form sodium aluminate. Sodium aluminate formed in previous reaction is reacting with the carbon dioxide form solid hydrated form of alumina. The remaining part of solution is sodium bicarbonate and the impurity sodium silicate. Both are in dissolved form, can be removed by using filtration. And after filtration we will get solid hydrated alumina. Then this solid form of Al2O3, further heating we will get solid pure Al2O3, and remaining volatile impurities and water will escape from the bauxite. The whole process is achieved through chemical process are called leaching. Metals like gold and silver can also concentrated by using leaching. We know gold and silver present in earth crust in free state. But at the time of mining, gold and silver can also contaminate with the impurities. So these impurities can be removed by using chemical process. And the whole chemical process explained here by using some equations. First, we take impure metal. Here the impure metal is either gold or silver. And this impure metal react with the sodium cyanide, water and oxygen to form a coordination complex. About this complex you will study in 9th chapter of class 12th. And this particular complex again reacts with the zinc to form another coordination complex of zinc. And the second product is solid form of metal. But this solid form of metal is purest form of metal compared to the first metal. And the second step we can explain in detail like this. The metal zinc, when react with the MCN2, the metal zinc will displace the metal from the complex. Why it displaces? Because the zinc is more reactive than metal present in the complex, because we know metal present in the complex is silver or gold. It's very clear silver and gold are less reactive than zinc. So this step is called displacement reaction, and this whole process we can explain in one more way using different examples. For example, gold. Same example we can explain by using gold and silver. Gold, sodium cyanide, water, oxygen, first form complex, and the complex react with the zinc, undergo displacement reaction to form another complex, and finally we will get pure gold. Silver also can purify in the same way. Remaining sections of metallurgy will explain later in part 2. Now let's see the summary of the topic described today. Metallurgy is the process for the extraction of metal from its ore. Gangue are the earthy impurities present in the ore. Magnetic separation is effective in those cases in which either the ore or the impurities are of magnetic nature. Hydraulic washing is used for the purification of oxide ores. Froth flotation process is used for the purification of sulfide ores. Leaching is used to concentrate an ore by chemical method. The whole metallurgical process in simplified form is given in this flowchart. You can just go through it. And here in this table the different chemical formula of ores of different metals are given. For example, hematite, the ore is Fe2O3 and it's ore of iron. For copper, the ore is copper pyrite, copper glans. Aluminium, the important ore of aluminium is bauxite. Lead, galena, and manganese, pyrolusite. These are the important ores of different metals. Now let's see some practice problems related to today's section. Question number 1. Name some ores which can be concentrated by magnetic separation method. Question number 2. What is the significance of leaching in the extraction of aluminium? 3. What is the role of depressant in froth flotation process? 4. Pine oil is generally added in the froth flotation process. Explain. 5. How do we separate two sulfate ores by froth flotation process? Last question is, name the ore from which aluminum is normally extracted. Dear students, try to find out answers of all these questions and write down your answers in notebook. Please watch the video repeatedly and learn the chapter thoroughly. All the very best. Thank you.